All right, Abby, you can go ahead. I have started the recording.
All right. Hi, everybody. Thank you for joining us today for this webinar. I'm Abby. I'll just be here listening, but we will send out a recording of the presentation after the presentation. You will also receive a PDF version of the presentation in an email and a survey. So we really appreciate your feedback. Really would appreciate if you took the survey. I'm just going to pass this on. Oh, also, if you have any questions or have anything to say, there is a questions tab on the left panel, and you can use that. And Misty will answer questions throughout and after the presentation. And now I'll pass it on to Misty.
Thank you, Abby. As Abby said, my name is Misty Hansen, and I work with our electric resistive product line and also our gas-fired product lines as well. So I know there's a lot of similarities between the RTS and the GTS that we launched a couple of years ago. So that's a good thing to keep in mind as we go through some of this stuff. Of course, the RTS humidifier is our electric resistive humidifier, our new electric resistive humidifier. And like Abby said, if there are any questions throughout the presentation, you guys are all muted, but you can type in questions into the question box on the left-hand side, and I will stop every few slides to answer those questions. So what I will do is I will share the presentation now, so you should be seeing that. What else? We do have another webinar next week, and that is going to be focusing on the controls of the RTS humidifier. We're going to get into a lot of detail about different ways of draining and controlling water level. These are all things that are newer with the RTS and also the GTS LX as well. So that'll be good if you just want a refresher on the GTS LX. And then as far as ordering this new product goes, April 12th will be the day that you will be able to start selecting it in DriCalc. And it will also be available to order that day. And then we're going to start off with a 6 to 8 week lead time for the RTS. This is the same lead time that we have for VLC. So it will obviously get shorter as we get more into production, but that is what the lead time will be. And if you have any opportunities to get the RTS spec'd, just make sure you talk to your sales team, inside sales, or your RSM about it, and they'll be able to help you out with anything that you would need. Okay, so let's get started. We're going to cover a lot of things today, and I did do this webinar yesterday, and I went over by about 10 minutes. So there's a good chance I will do that again today. If you have to go in an hour here, go ahead and just log off. Otherwise, stay on. But I will keep presenting just so we can get this presentation recorded. And then that will be emailed out to you afterwards, like Abby had said. So you can just watch the tail end of it at that time if you need to. All right. So as far as our agenda goes, we're going to do an overview of the models, talk about the amps, weights, capacities, all that stuff. We'll talk about the features of the RTS. These are the things that come standard. We'll go through the principle of operation, talk about some of those critical components that help us maintain steam output with the RTS. Then we'll talk about options. These are going to be things that you can select in DriCalc. And one of those is, of course, a new SDU for the RTS humidifier. Um, and then we'll look at a dry calc selection. We won't be going into dry calc, but I did take some screenshots that I have available, and we'll just kind of, I'll point out a couple of things specifically that are going to be different with an RTS selection. And then I'll do a pricing comparison between vapor mist and VLC, and of course RTS right at the tail end. Um, so let's get started. All right. So as far as the models go, the model naming goes like this. We have the RX, which is the series of RTS that this product is. And then the hyphen, the first number there is going to be the capacity in pounds per hour. And then after that last hyphen is the number of heater stages that the unit has. So after we reach so many amps in one stage, we have to add another stage of heaters. And that's how we get the 1, 2, 3, or 4 at the end of the model. So the bigger the humidifier, the more stages it has to have. And then the stages also determine the physical size of it, not just the capacity, but the physical size of it as well. And we'll get into that in a little bit. But I just wanted to pull up the models tables. So we have a lot of different models, a lot of different voltages. The RTS will be covering every voltage kilowatt combination that the Vapor Stream did. Of course, the Vapor Mist as well, but the Vapor Stream did cover a broader range of those voltages. And so that was one of our goals, was to make sure that we covered off on all of the voltages and the kilowatt combinations that the VLC was offering. So then you can see the capacity on this goes up higher than what the VLC does today. And actually, it's the highest capacity electric resistive unit on the market. Hopefully you can use that when another competitor might be needing to put in 2 or 3 units to reach that capacity. This is just an extension of that list. Like I said, lots of models just to cover off on all of those voltages in single phase and 3-phase there. So, and then these are the European models. They're just a little different because of the heater that we're using for 230 volt. It's actually a D-rated 240 volt heater, so the capacities are a little bit less there, but these are going to be the models that are available in Europe. And then the rest of those are on this slide. All right. So just to get into the sizes of the units a little bit, I had mentioned earlier that the stages determine the size. There are basically 3 different sizes or footprints of the RTS humidifier, and they all house different stages of the unit. So this small enclosure will house all of the single stage units. So anything with a -1 is going to be in this size of enclosure. The maximum capacity of this unit is going to be 75 pounds an hour. It's a little bit bigger and heavier than a vapor mist for comparison. The weight is bigger because of the tank itself. The RTS tank is larger, and it is also a 14 gauge 304 stainless steel tank, which the vapor mist humidifier is actually an 18 gauge tank. And then the vapor stream is also that 14 gauge tank like the RTS is. But that kind of increased the weight of our RTS. But, we really like the way the 14 gauge tank, the way the 14 gauge tank withstands use. And we never have any problems with them. So we wanted to carry that feature over onto the RTS. It just, the consequence there is it gains a little bit of weight. As far as the dimensions, comparatively, it is a little bit bigger than the Vapor Mist. However, our clearance recommendations are less than the Vapor Mist, significantly less. The left-hand side actually doesn't have any clearance. We say 2 inches just so that there's some airflow along the side there. And then the right-hand side, we just have what we recommend is 6 inches to get that side cover off. You can see that there's some screws on it. If you ever needed to take that off, you would need to be able to get a screwdriver in there and loosen that up to pull that side off. Standard maintenance is not going to require that right-hand side to come off. You can access everything from the front. It would be if there was something else going on that you needed to get into that side. Otherwise, the left, right, and top covers should pretty much stay on all of the time with the humidifier. Okay. The medium unit is going to be the same style the same design as the small unit. It's just a little bit bigger. And the medium unit is going to house anything that has a -2. So all of our 2-stage units are going to be in this size enclosure, this size of tank. The maximum capacity for this one is 162 pounds an hour. You can see that our weight jumped quite a bit there, and the size is a little bit bigger as well. This one is going to have the same clearances as that small unit. So you still have the benefit of little to no clearances on the left-hand side there, and then the 6 inches on the right-hand side. And then a change with this one is that this 2-stage unit can be wall mounted, or it can be mounted on a stand. And we'll see that stand in a couple of slides here when we take a look at the large unit. But it is a nice stand that matches. It's a black stand that matches the design of the unit itself. And then I don't think I mentioned this with the single stage units, but those ones can only be wall mounted. They don't have a floor stand, and they can't be supported from the bottom. They have to be mounted on a wall. All right, and then this is going to be what the inside of both the small and the medium units, so the 1 and 2 stage units. This is what they look like inside. So you can see the tank is on the left-hand side there. The heaters are on the bottom. That the plate is covering them up, and then we have the temperature sensor right above that. That will cut the power to the heaters if there's an over temperature situation, and that's just to protect the heaters and to keep things from getting too hot inside the tank. That's a safety that is required for humidifiers. And then on the right-hand side, you have the control cabinet, and you can see that you can access the control cabinet from the front of the enclosure itself. Having the right hand panel off would provide you more access, but our goal was to keep most of the access from the front. So we widened up the control cabinet there to make it easily accessible. And then behind the control cabinet and underneath of the control cabinet are hoses for drain. You can see the drain valve right there underneath. But behind that and to the right, there are the fill hoses. And then we actually have an integrated P-trap on the overflow port that with Vapor Mist and Vapor Stream, that actually had to be installed in the field as part of the installation. So having that integrated does save a step in installation compared to the Vapor Mist and Vapor Stream. Okay, so there is a question. Can the entire tank be easily removed for cleaning and service? If so, roughly how long does it take to remove? So the tank is not as easily removable as a vapor mist. I don't know how many of you are familiar with how easy that is to take out, but the design of the vapor mist does allow for the easy removal of the tank. This one is not as easily removable, and I don't have an exact time. That's something that I can find out. I'll just get that information. The instructions on doing it are in the IOM if you want to take a look at that. All of the brochure and the IOM and everything like that, those are available on the rep side of the website. If you guys want to take a look at them, that information is there, as well as guide specs and a couple of comparison charts and things like that. But I'll get the time estimate on removing the tank. It's kind of somewhere between Vapor Mist, where it's easily removable, and Vapor Stream, where the humidifier or the tank is the whole humidifier, so you can't really remove it. Okay, and then yes, okay, we'll just mosey on here. Okay. Okay, so then we'll move on to the large unit. It's quite a bit bigger than the small and medium units. All the dimensions and the weight are larger. The large unit houses the 3 and 4 stage unit. So this one actually has both models in there. And then the max capacity of this one is 324 pounds an hour, which I mentioned earlier is the largest electric resistive unit on the market. And then this one can be mounted directly on its base, so directly on the ground, or you can get the floor stand with this one. This is an example of what the floor stand would look like for the medium unit as well. It's about 20 inches tall. And then just a note on the water and the drain lines, those connections on the single stage and the 2-stage units. Those connections are going to be coming in from the bottom, and that was a decision that was made to alleviate needing space on the left or the right hand side. Those are going to come in from the bottom. And then this larger unit, the connections are actually on the right hand side, because standard for this unit is to be base mounted. And obviously you can't run the drain and water connections from the bottom at that point. So if you did have a space constraint on the right-hand side of this unit, the large unit, we do have the option to actually rotate one of the valves, rotate the fill valve, and then your connections can come from the bottom. If you have the stand, you can run your connections up from the bottom if you wanted, or if you needed to. That is an option with this larger unit. And then just another note, we have those black rectangles on the enclosure. Those are handles to take that front cover off easily. And then we have quarter turn latches on the front panels, the front black panel and the front gray panel, to easily remove those covers. So you don't have to worry about losing screws or anything like that. All right, and then the clearance on this side, because the connections are on the right-hand side, the clearance is larger. I believe it's about 24 inches, just to account for having your drain and fill lines coming in there. That can be reduced if you get those coming in from the bottom. All right, so clearly, the large unit looks a little different than the small and the medium. We did end up putting the control cabinet on top of the tank for the large units, because putting it off to the right-hand side got it too wide for a footprint. So the control cabinet is above the tank. The steam outlet actually comes up over on the right hand side there towards the back. And then this one, it looks like there are two tanks in there. Really, it's just 2 doors on one tank. And we did that because they are 14 gauge doors on that unit. And even without scale on them, they're pretty heavy. So we did the 2 doors pretty much just for weight. Once those get scaled up, they are pretty heavy. So that's why we went to 2 doors there. All right, and then let's see. All right, there's a question. For the 3 and 4 stage units, how is the access to the control panel components shown on top of tank for external wiring connections? The top cover, easy access, or is the question is pretty much asking about the access to get to those components in the control cabinet, and they are easily accessible. Just the way they are. There is enough space above the control components themselves to see back in there. And then the way it's designed is the components that you would need to access are sitting up front more. So like the Vapor Logic board is sitting right there at the front. So it's easy to get to. Another question about plans to create an LMH, a low maintenance humidification system with the RTS. And that is something that we haven't looked at, and we're not planning on doing that. That's kind of we're kind of reserving that for the vapor mist. Okay. Let's see. I will move on here.
Hey, Misty, did you see the question in the chat?
Let me take a look. Or actually, could you read it to me, Abby?
Yeah, if the wiring is above the unit, how does the wiring cope with the temperature?
Yeah, so that was a concern that was originally actually came up when we moved the control cabinet to the top of the tank. And it actually, so what we ended up doing is we insulated the top of the tank. So there's a nice layer of insulation between the control cabinet and the tank itself. And then also you can kind of see on the right-hand side, Yeah, you can kind of see on the left-hand side, there's actually a vent that is built into the enclosure that brings cool air into the control cabinet. And that's how we are able to keep that control cabinet cooled down. So it definitely, that was definitely thought of as we were designing it. And this, so the temp rise is something that we have to pass through agency, and we were able to do that just fine. Okay, another chat. Nope. Yes. Is that a vent fan? Is the vent a fan? Yeah, there is a fan in there. It pulls air in. Okay. Okay, let's talk about some features. So these are going to be things that are included in all the units. I'm going to pick out some specific ones here if you just want to look over the list. We're able to maintain the plus or minus 1% control. Of course, that has a lot to do with whether or not your temperature is staying the same. That is kind of the key there. We do have single stage SSR control on every RTS unit. We are not offering 100% SSR with RTS. We're keeping that for vapor stream. We're still able to maintain the plus or minus 1% with the single stage. The control is the same. It's just the control is the same, but I know there are other reasons that people would pick up 100% SSR over single stage. And then we do have integrated drain water tempering on all of the RTS units. That operates the same way that it does for the GTS LX. So when we go over that in a couple of slides, that can just be a refresher for you for how that works for the GTS LX as well. We have BACnet as standard. So there's not an additional charge for BACnet. We have the touchscreen control, and then a couple of VaporLogic features that we carried over from GTS LX are Smart Drain and Universal Water. So Smart Drain is where we use the conductivity of the water to determine the drain rates, how often it drains. And then Universal Water is just the idea that we are using only the conductivity probes to detect water and no float valves. So we just use the one method of water detection, and that's Universal Water. And then we also have a new gasket type that we are using for the RTS, and we've had really good success with this gasket. All right, and then a question, how do you access the touch screen in order to update the firmware? Yeah, so that's something that's new with the touchscreen display is that something that's new with the touchscreen display over the keypad. So the touchscreen display does have to be updated. It doesn't have to be updated, but it should be updated when you do a VL6, a VaporLogic upgrade or update. You should update your touchscreen display as well, so they can continue to talk well with each other. So that to access the touchscreen display is fairly easy. You can just reach around the back on those larger units, and then the small, the medium, and small units, that right-hand panel that's black, that actually lifts off, and you can just plug it in right there in the back. So it is pretty easy to access that. to update the display. Okay. I will move on with features. So I'm going to just talk a little bit about some of the features in a little more detail. Some of these things are going to be important for the next topic, which is going to be principle of operation. So the conductivity probes, this is what we use to do universal water with, detecting RODI water and potable water with the same method. These conductivity probes are different than the conductivity probes we use on our older generation of products. So those still require the float for RODI water and then the conductivity probes for potable water. All right, so the conductivity probes, these are kind of our bread and butter of controlling water level. This is how we do it. The main operating level for the RTS humidifier, the water level is going to be between the bottom probe and the top probe. That's where it should stay. And then the top probe there is the overflow probe, and it actually detects foam. And when it detects foam, it will do a full tank drain, and that is to protect the heaters. We don't want those to be operating when the tank is actually just full of foam and there's no water in there. And then, of course, it will shut down the humidifier to save those heaters if the water level drops below the lowest probe. For some reason, if it does drop below that low probe for too long, we'll cut the power to the heaters to protect them and the unit itself. Okay. All right. A couple of other things that are key to the principle of operation are the valves. We use 2 fill valves for the RTS humidifier. This is similar to the GTS LX that also uses 2 valves, a precision fill valve and then a fast fill valve. And the fast fill valve is used to fill up the tank initially, and then the precision fill valve maintains the water level as the steam leaves and we need to recoup that water. So the reason we do this is because if we added water with the fast fill valve, we would be quenching the boil and losing our steam output every time we added water to the tank. And that was the glory of the float valve, was that we used with RODI water. The beautiful thing about that was that it just trickled in water very slowly, and it didn't quench the boil and cause you to lose steam output. Now that we don't have that option, we don't have the float valve option anymore. This is how we're accommodating for that. We are using the precision fill valve to slowly add water to the tank, just like that float valve that we used to have. And then the precision fill actually does come in below the water line, so that also helps with not quenching the boil. If we were to just dump it in right on top, then we would be losing our boil there and still losing steam output. So we had to do a couple of things in order to maintain that steam output, but it ends up working very well. And then the drain valve, there's not much to say about that. It's just a full port ball valve, and it is the same one we use on GTS LX. Okay. This is a nice diagram, a nice drawing just to see behind the control cabinet. We always have the control cabinet sitting in the front. And you can see that the drain valve and the fill valves are accessible underneath of the control cabinet back there. And then you can see the trap that comes off the overflow. And then the rest of those hoses that go up, those are the fast fill and the precision fill hoses. And, you know, some of the stuff at the top where those two connections are, having two fill lines means we have to come up with creative ways to prevent backflow into the water feed. So those hoses up at the top have a lot to do with preventing backflow. So we don't need any additional backflow prevention outside of the unit. It's all built in. We had to get a little creative with that. So I will show you the next one. This one is just actually the tank of the humidifier. So you can see that whole front panel comes off, and the initial concern with this type of design is water coming out when you take the cover off. We did design it to have a slope. So you can kind of see, if you look inside the tank, the back and the front are sloped towards the drain port. So that keeps the water away from that front cover. It works very well. And then this is just it's kind of nice to see the tank without any of the hoses, just to kind of see where things are getting connected. You can see the drain port is right there at the bottom, and then that precision fill port is underneath the water line. Just kind of to see where things are in relation to each other is nice. And then this pressure equalizer for the precision fill, that has to do with the backflow prevention for the fast fill line. Since it is under the water line, we end up pulling air from the top of the tank when we do a backflow prevention test. So that's the point of the backflow prevention test. We want to be pulling air and not water from the tank. Okay, I'm just going to walk through the principle of operation. I'm going to go pretty quick. It's pretty simple. The most complex part is the fill valves, having the two fill valves. The heaters are placed right there at the bottom of the tank. You can see that. So this is showing the fast fill. You can see that the fast fill actually comes into the tank and then drops down and points at the drain port. That acts as two things. We use it for our integral drain water tempering, but also it keeps the drain port nice and clean. It actually kind of like blows the scale away from the drain port to keep the drain from getting clogged up with scale. It's pretty neat to see it actually when it's been running for a while and there's scale in there and you take the cover off. It looks like a little bomb went off right by the drain port. It just keeps all the scale away from it. It's a pretty neat thing. And then, so our fast fill valve will come on, our precision fill valve will come on when we initially fill the tank, just to get as much water in there as fast as we can. And then, of course, the operating level I mentioned on the conductivity probes is between the bottom and the middle probe. Once we start boiling, of course, our steam leaves and we need to add the water, and we'll add the water with the precision fill, like I mentioned, to not quench the boil. And you can see that in this rough drawing that it does come in below the water line. Okay, is there a drain plug on the side? This is a question, sorry. Is there a drain plug on the side of the tank in case the drain is blocked with scale? Only removing the tank front plate could be a problem if the tank still has water. Yeah, so actually, there's a couple of things that you can do. Let's see, a couple. So there is a port at the bottom of the tank towards the front that isn't connected to anything. It's kind of a multi-use port. We seem to just kind of throw those on our humidifiers and people find uses for them. That is what could be used if your um, if your tank or if your drain is scaled up. The other thing, and this is what might be easier, would be to so the drain is actually, so it comes out the side of the tank and then it goes straight out to your connection. So if you want to disconnect your drain off of there, you can actually just like the drain line will be clear, and it's a straight path, so you could just stick something in there and break up the scale and then let it drain out. So there's those two options to get water out of the tank if your drain is blocked, because that is a good point. Okay. All right, let's continue with our principle of operation. And then, so after a while, of course, we have to drain just to get the built up chlorides and minerals out of the tank. And we have a temperature sensor in the drain block. That's that little green square that you see. That helps with drain water tempering, and it gives you a readout of what your drain water temperature is on the touchscreen display, so you know that. And then when we fill the humidifier back up with water, we will skim at that time to get any surfactants off of the surface of the water. And then you can see that P-trap there as well. And then, of course, we drain back down to operating level. All right. I want to talk a little bit about how we do drain water tempering. And as I mentioned earlier, this is the same way we do it with RTS RX, so a good refresher. This is a change from, this isn't how the drain cooler works. So this is a change in how we do this. But this text is in both the GTS IOM and in the RTS IOM. If you ever need a refresher on how the integral drain tempering works, that'll be a good place to look for that. Okay, so what first happens is the temperature sensor that I mentioned a slide ago, that will sense water greater than 140 degrees. And what will happen is it'll send a message back to VaporLogic and say this water is too hot. VaporLogic will turn on the fill valves. And you can see that fast fill valve is in that drop tube. So it starts at the top, comes down, and it shoots right at the drain. So what's happening there is the cold water from the fill valves and the hot water are mixing right at the outlet of the tank. And then the drain valve will open and we'll read that water temperature again. And it'll keep communicating back and forth with VaporLogic. And VaporLogic will keep communicating back and forth with the drain and the fill valves to make sure that the water temperature is less than 140 degrees. At the same time, VaporLogic is making sure that we're not cooling it, super far beyond 140 degrees. And we do this in order to conserve water. So you're not using more cold water than what you need to get it down to 140 degrees. We're not just dumping water at it, not knowing what the temperature is. We know what the temperature is, and we're not going to temper it too far. Okay, so here's a question. Do RTS outdoor enclosure units require an additional drain cooler since the integral drain tempering only works when you have power? The RTS outdoor enclosures have a thermostatic drain valve built into them in case of a loss of power. So you don't need to buy an external tempering device for RTS outdoor enclosures. Yeah, and we'll talk a little bit about that. There is a device that you can buy for indoor enclosures for different reasons if you needed them, and we'll talk about that in a little bit. But it's essentially the same device that is built into the outdoor enclosures. Okay. Another question, can we return condensate from the dispersion grid drain and eliminate the need for a separate drain cooler? Yeah, so actually the port that I had mentioned earlier about using it using it if your drain was blocked, that can be used for condensate return. It's the same size of a condensate return port that's on, say, the vapor stream or any of our other humidifiers. So that is an option to return the condensate and eliminating the need for that separate drain cooler at your dispersion. Okay. All right, I'm gonna move on from drain tempering here. All right, I wanted to talk about draining a little bit. We're gonna get into this a lot more next week. There are 5 different types of draining options that you can pick from. Smart Full, the one that's bold, that is what the humidifier ships in. That's what we recommend using. What that does is, I talked about Smart Drain. It's actually, so Smart Drain, what it is the more conductive your water is, the more often we would drain it. And then the less conductive your water is, the less often we would drain it. So if you're using RODI water, you could go a really long time without needing to drain the tank. However, with more conductive water, you will drain it more often. So we recommend using Smart Drain. I know that people are a little concerned about using Smart Drain. They're worried, is my humidifier just going to start draining in the middle of the day or when I really need it? Is it just going to start draining on me? It actually ships from DriSteem scheduled to only do a drain at 12 a.m., so midnight. And the only time the humidifier would drain outside of 12 a.m. would be if the humidifier detected foam. So on that top probe, if that top probe detected foam, it would do a full tank drain to clean the foam out of the tank and start over. So that is kind of how we do Smart Drain. Smart Drain can be scheduled for any, there's a window you can schedule it to only drain at a certain time of day. You can schedule it to only drain a certain time of the week. But that's your limitation with Smart Drain. We really just, with Smart Drain, we really just need an hour out of the week and to drain that tank. Okay, we have a question. Can you produce steam during drain water tempering? That's a good question, and I can tell you thought all the way through that. We can't produce steam while we're doing drain water tempering. So we have this new feature called mini drain. And I think I'm going to answer your question when we get to that point. But when we're doing full drains, obviously you're not having any steam output because you're draining the whole tank. With mini drains, that's the point of a mini drain. We only drain a little bit of water out so you can maintain your steam output. However, you do have to use an alternative form of tempering at that point. And we'll talk about mini drain. That is a significant change that we are offering with RTS. So I want to make sure that we get that covered off on. And that is next week in the controls and the draining and the water level control. We will get into that in excruciating detail. But here, I just want to make sure we can. Okay. Perfect segue to mini drain. I see we have a chat. Abby, could you read me the chat, please?
Yes. Can the drain be programmed by usage rather than a time of day?
Oh, yeah. Sorry, I didn't really clarify that. So I only talked about smart drain because that's my recommendation. But you can also change it to user drain. You can set that to be tanks boiled or cycles of concentration. That one is, you're in control at that point. We don't limit you on that. If you really can't, if smart drain isn't working out for some reason, and probably the best thing to be to call into tech support and make sure you're using that correctly. Because what could happen is if you put too much time in between your drains, you could start having issues with having too many foam drains. Foam drains will just happen when they need to happen. We don't wait until midnight. We can't wait until midnight to do that. So it's a give and take a little bit there. All right, so mini drain is a new feature. We will be launching mini drain on the RTS RX as well in the future here, but you'll see it on RTS first. It is, we only drain about 20% of the tank. And what we actually do is we keep the heaters going. We slowly fill up the tank to skim, and then we drain the tank back down to operating level. But what happens with mini drain, as I mentioned earlier, we can't use the integral tempering because our heaters are running and the tank is hot and boiling, and then adding cold water to the tank at the same time we can't do it. We can't keep the drain temperature low enough, and it makes some god-awful noises. I have experienced this. So what has to happen if you need mini drain? And mini drain is going to be used excuse me. Gosh, someone calling? Sorry about that. So mini drain is going to be used when when you can't do a full tank drain, when you need output 24/7, or if you're trying to alleviate foam drains. If you're having a big problem with foam drains, draining, continuous draining, but just a little bit is going to be able to maintain your steam output. while quenching the need or quenching the foam that might be showing up in the tank. So mini drain is used in pretty unique situations. It is now a question in dry calc that you will be asked, and we'll look at that in a second here. But that's mini drain. And basically, you're just draining less water more often and maintaining steam output continuously the whole time. Okay, let's see here. All right, probe checks. I won't get into probe checks too much. Basically, what a probe check is it makes sure that we're reading water with the probes. We don't want to get into a situation where we think we're reading water, but we're not. Like maybe the probes get scaled up or something. It says that there's water there and there's really not. Obviously, we could have an over temp situation in that case. So every now and then, actually, I can say specifically when there's a drain, when there's a full tank drain, it will do a probe check. It just needs to read the conductivity of the water, and it needs to get the water off of the probes and do a clean reading to make sure that there's a difference between the two. And that is kind of what a probe check does. Like the key is that bottom point is that it won't interfere with the operation of the humidifier. It only does it when there's a drain.
Hey, Misty.
Yep.
We have it says, can the skim program still be timed, i.e. in seconds? Example in seconds.
Yeah, you can. The skim is still an adjustable amount of time. All right. All right, so I'm nearing the end of my hour. No surprise that I'm going over. I just have a lot to say. Okay. We have a question. Abby, could you read me the question? Actually, I got it. Okay, so currently on the GTS, a probe check occurs every 2 weeks, even if the full drain is disabled. Has this been updated? With the GTS, a probe check occurs every 2 weeks. Yes, and I actually think I know the specific job that you're talking about. It has been updated to only do a probe check when it drains. It shouldn't be doing a probe check every 2 weeks. I will check on that. I don't know if that's been released or not, however. But we did update the Vapor Logic controller to do that. To not do that, I guess I should say. Yep, probe checks should only happen when there's a drain. Okay. All right. All right. So there are lots of options. I'm sure you guys have taken a look at this slide. These are going to be things that are options in dry calc. Most of these things should look fairly familiar. The differences, I know I mentioned this earlier, the mini drain is a question in dry calc. And whenever you turn on mini drain, even if the unit is already out in the field, you can still turn on mini drain. You will get a big old message on your touchscreen display that says, hey, if you turn on mini drain, just so you know, your integral drain tempering is going to shut off. And that's the warning that because mini drain shuts off that integral tempering, we just need people to be alerted to that fact. If you select mini drain operating mode in dry calc, we will turn on the mini drain operating mode. We'll disable the integral drain tempering. And then it doesn't automatically include a alternate mechanical tempering device. That is a question that you will have to answer later on. And I'll kind of show you how that's going to work, just so you have that background information going into it. I guess the other thing I wanted to point out on here is we do not have seismic certification for RTS, but we do, we are planning on getting it. It's been taking a very, very long time to get OSHPD certifications. So it will be a little bit, but it is something that we're planning on doing. All right. All right, so we do have the outdoor enclosure for every size of RTS, from the smallest to the biggest. The small ones, this is a new feature. The small ones can be mounted on a wall, as well as being mounted directly to their base or curb, or on a curb. We have multiple different curb heights. And we are planning on getting these outdoor enclosures seismic certified as well in the future. Okay, so this is the mechanical tempering device. This is what will be integrated into all RTS outdoor enclosures. And what happens is we put a normally open drain valve on our outdoor enclosed units, so that when there's a power outage, we will drain the tank of water. That drain will just open when the power goes out, and then we won't have to worry about the water freezing in the tank, because that would be detrimental to the unit if it froze. The whole tank just froze. So we do put a normally open drain valve on outdoor units, but then what happens is if we don't have any power, we can't use our integral drain water tempering. So hot water would be getting sent down the drain during a power outage. And obviously we don't have this problem for indoor units because they have a normally closed drain valve on them, because we don't have to worry about them freezing. I hope we don't have to worry about them freezing. So that's why we have this mechanical tempering device. It's not, it doesn't use power. Basically what it is it's a drain cooler, but it is a different style. It's a little bit smaller, and it works better with the drain rates for the RTS. So this is integrated into all outdoor enclosures. This is what you need if you are going to use mini drain. This is the tempering that you would need to use. Another reason you would use this, this has been a request on the GTS LX. So the way we do the integrated tempering, you have to temper with the water that you're using in the tank. Since the mixing of the hot and cold water happens in the tank, you can't use potable water to temper with and then ROD water in the tank. This is how, using this device is how you could get around that. So what you would do is you would shut the tempering off in the Vapor Logic controller, and then you shut the tempering off in the Vapor Logic controller, hook this up, and then this would do your tempering instead. But you could hook up a separate cold water connection to this device and then use your RODI water on the humidifier connection. So that is how to get around that as well. So you could pick that, you could pick this if you wanted to do that. And that pretty much covers off on that one. This is an option in dry calc, and we'll see that in a couple seconds here. There isn't, I'm just gonna quickly go through the SDU. There isn't a lot different about the SDU. We did not really change the design of it at all, from the vapor mist to the RTS. The capacity ranges are still the same. We have the 30 pounds an hour for the SDUI. We can go up to 102 with the E, the SDUE. The blower itself is still the same. I know that it is loud. We have gotten that complaint a couple of times, and what we're doing is kind of, or we're attempting to try to make it quieter, but we couldn't quite squeeze it into this specific design or project. So it does have the same enclosure type as the RTS. It looks nice, it matches. But it is still, the design is still the same as the vapor mist. And then, of course, just a note there is, if you select Power by Others in DriCalc, that is going to be, you're going to get the unit, and it's going to just be, you have to connect it in the field to 120 volt power. If you select DriSteem, we have to put a transformer in it, and it's going to cost you a little bit more money. So just to kind of make that connection there. That's the same way it is today, but just a good thing to know. Okay, I'm just going to skip through that you can read through on your own if you're also interested. All right, DriCalc. I feel like I'm running a race. All right, so this is just a DriCalc selection. Like I said, I just took screenshots. So you can see here, we always list the RTS first, and then the following electric resistive units. And I mean, even on something to point out on this slide is the vapor mist at the capacity that we have chosen, 185 pounds an hour. We do need 2 vapor mist units. So obviously not the right choice to choose vapor mist in this situation. All right, so this will be the first few questions for RTS. You'll get asked about mini drain right away. And if you select yes to mini drain, I'll show you what will happen later on. So I picked yes to mini drain here, and just another thing, there's a little question mark there that will help explain what mini drain is. It'll kind of explain the things that I had talked about when I was talking about mini drain. So that's just for some guidance. And then, so if you select yes to mini drain, a couple pages later when you're picking accessories, you'll get this question right at the top there. It'll say integral drain tempering. And then that is not a question that you get to pick. It will either be locked on excluded or it will be locked on included. So if you pick mini drain, that's going to pop over to excluded. And then you're going to be asking the question, why is my integral tempering excluded? And the answer will almost always be because you picked mini drain. Otherwise, you will have the integral tempering will say included. So that's kind of how that works. Again, you don't get to pick that, the answer to that question. That is just pretty much for your information, kind of as a red flag that you're not going to have that integral tempering. And then the secondary question there is going to be alternate mechanical drain tempering, which, we have little help question marks. We have help question marks there to help get those questions answered. So the alternate mechanical tempering, if your integral tempering was excluded and you needed drain water tempering, you would need to add the mechanical tempering there. Other than that, though, other than those 3 changes, the dry calc selection is gonna look very familiar to any current dry calc selections. There are a significant amount less questions you have to answer with RTS than both vapor mist, but especially vapor stream. There just aren't that many things that we need to know because so many things are just added into it automatically. Okay, and then we have a question about the sound rating of, I'm assuming the SDU. The sound rating for the SDU is, I don't know the exact number, but it's between 58 and 60. It's right in that range. Like I'm gonna average it out and say 62 decibels for the sound rating on the SDU. I know the I and the E have different different sound ratings, but it's about 62 if I were to average them out. So it's not quiet. Okay. Okay, and then Abby's just talking to people. All right, I'm gonna finish this up, I think, here shortly. Okay, just finishing off the dry calc selection. Like I said, same questions. Okay, I'm gonna finish with some pricing comparisons, and these might just be good for you to look through on your own if you wanted. But what I did is I listed out our base price for each of the VLC, the vapor mist, and the RTS. And the base price of the RTS is more expensive than the base price of the vapor mist. But after you go through and you'll add drain tempering to each model and you add SSR to each model, backnet to each model, you mount the control cabinet for vapor stream. And I didn't even include some things on here. Like if you needed RODI water, that would be an upgrade for vapor mist and vapor stream. If you needed end of season drain with RODI water, that would be an upgrade for vapor stream and vapor mist. So those aren't even on here, and the RTS is already significantly less expensive than both the vapor mist and the vapor stream. We understand that not every unit needs drain tempering and SSR and backnet, but that's why the price is lower. That's why the price is the way it is, in order to compete with our base model vapor mist. All right, so that last one, that was just a 6 pound an hour unit. This is 102 pounds an hour, which is the largest vapor mist that we sell. So again, a huge difference. The vapor stream just keeps climbing there the bigger we get. And then the last one example that I did was 285 pounds an hour, which is the largest vapor stream. So we obviously don't have a vapor mist at that size, but still the RTS is less expensive. Every model is going to be less expensive than equivalent vapor mist and vapor streams. So that's good. Very, very good. And the outdoor enclosure is significantly less expensive for RTS than it is for vapor stream. And I hope that allows us to sell, to win many more jobs here. All right, that is all I have besides answering some questions. And I see that we have some already. All right. All right, is the intent to phase out the vapor stream and vapor mist models? We're definitely considering that with the RTS being having all these features integrated into it. We don't have any plans to do that right now. We understand that the vapor mist and vapor stream have been around forever. So we kind of we need to get the RTS out there first before we make any plans for that. Will we be able to get an electrical spec chart listing recommended fusing line current, just as we do have for VM units? We will likely have this requested from consultants as well. Yeah, so I know what you're talking about. We don't have that for RTS yet, at least not a published document. It is sitting in engineering. So yeah, I will make sure we get that available for you guys. Okay. If they want to mount above the ceiling, how difficult would it be to clean? It would be pretty difficult to clean if it's above the ceiling. One thing that is nice about this unit is since that whole front panel comes off, and actually this is something that engineering is really excited about, is they're looking at doing some kind of tray for like in the future to, there's actually quite a bit of space below the tank and the bottom of the enclosure. So they were looking at some kind of tray that you could just keep down there and scrape the scale off into the tray, which makes it a lot easier for cleaning. I mean, when we have to clean them in the lab, that's what we do. There's no lip on the tank, so you can just, brush the scale off into the bucket or whatever it is, and you go on your way. But like I mentioned earlier, removing the tank is going to be more difficult. I know that is a common use for the vapor mist. They can just take the dirty tank out and replace it with a clean tank, go clean the dirty tank. That's going to be a little more difficult with the RTS. All right, another question here. With respect to full insulated tank option, is the standard uninsulated tank? Yeah, so there are, the standard is uninsulated tank. We do put insulation where it has to be on the standard unit. So between the control cabinet and the tank, we'll always insulate that, whether you pick insulation or not. That is a safety, we do that for a safety reason. But to get the full tank insulated, that will be the add-on there. Okay, and then is the control section vent fan tied to Vapor Logic producing a fault if the fan fails to prevent damaging boards? I am not sure. I don't believe it is. I don't believe the fan is tied to Vapor Logic, but I will find out. I'll get back to you on that. Okay.
And then you do have a chat, Misty.
Yeah, I see that one. Okay, this new unit is to replace the existing HT unit. So how long will the HT be in production for? Also, spares for the existing HT as a new unit will not be easily installed as a replacement. Okay, so the HT is basically the vapor mist in Europe. So we haven't really set a time for any kind of sunset of the HT or the vapor mist or the vapor stream. But if we do sunset these products, we always have a 10-year warranty. Not a warranty, but we always have parts available for 10 years. So that'll be a similar story here. We would keep the parts around for the 10 years after they were last sold. Yes, and I mean that's just another good point there that he makes. The heaters are not the same heaters that we use for vapor mist and VLC. Those heaters are used for both units, but the RTS heaters are made specifically for the RTS. Mainly because they go in the front of the tank versus dropping in the top. So that's kind of why the design of the heater had to change. But they're not interchangeable with vapor mist or vapor stream or HT heaters. So that's just a good point that he makes there. Okay. Are there any other questions that I can answer? I'm sorry that this went so long. I don't like rushing through it either, though. All right. If that is all, I will stop our recording here. And thank you all for joining us. We really appreciate you taking time out of your days to learn more about the RTS. And hopefully you can join us next week too. We'll get into a little more detail around some of that operation of the draining and mini drain and all that good stuff. So we hope to see you then. Thank you.